Hello guys, welcome back to Math Zone African Motives. We are still on our revisions, and this is our Mathematics N5, considering the March exam, which was written actually 27 of March 2026. So I'm just gonna quickly go through the questions and see how we're supposed to attempt these, as we have our introductions before. So make sure that you go through the introductions so that you do understand each and every part that I'm going to explain. So we are given the instructions and the information that was to consider, especially on your final answers to three decimal places, unless indicated differently from that question. So I'm not going to waste your time. Let us quickly go through these and see. Question number one, on 1.1, you're given the log of y in base of 3, and that is equal to this. Okay, so 1.11, determine the following limit. This limit that we are given. All right, so let us quickly consider our limit here. We do understand that if we are to consider the limit, we're going to simply substitute the limit that we are given. So we are given the limit as x approaches to 0. All right, so this is going to be into 1 minus cos squared of x over what? Over x squared. So in this case, if we were to substitute the limit, which is x approaches to 0, into the numerator, it was going to be 1 minus the cos. So that is put a bracket and have the cos of 0. All right, then you square that bracket because we've got cos squared. This was going to give us what? A 0. All right, in the denominator, x squared, 0 squared, that's what? That's a 0 again. So meaning to say, in this case, we are going to apply our L'Hospital's rule, where we are supposed to find the derivative of both the numerator and the denominator, given your f of x and your g of x. You're supposed to find their derivatives. All right, so that's the limit as x approaches to 0. And if we are to differentiate, 1 is going to give us a 0 minus the derivative of cos squared. The cos squared of x is the same as the cos of x squared. Remember, from our chain rule, the function of a function, of which you can do it by inspection, where we have got a power and the cos of the given function. So we're going to use power, then the function, and the inner expression, so that we can simply differentiate. So differentiating, looking into the power, you drop the power, then you subtract 1. All right, so it was going to be the derivative was going to be 2, the cos of x. We subtract 1 on our power, so that's to the exponent of 1 times the function, which is the cos. So cos changes to a negative sign of what? Of x. And the inner, which is the inner expression, that's x. If you differentiate x, is going to give us what? It's going to give us a 1. So meaning to say, this is what you're going to have. You multiply this on your derivative. So that was going to give us negative times what? Times 2. That's negative 2 cos x sine of x, or sine x cos x. It is up to you. Sine x cos x, like this. All right, so that is the derivative of cos squared from our function of a function, simply applying this concept. We've got the power, the function, and the inner expression. We can differentiate by sight, by inspection. Then the denominator, again, we need its derivative. That is 2x. Simply drop the power. So that was going to be 2x. And using the limit again, as x approaches to 0, you're going to see that here we're going to have a positive. Take notice where it was maybe a positive. Or let me just simplify before applying the limit. So that was going to be 0 plus 2, which is, it was going to be 2 sine of x cos of x over what? Over 2x, which we can cancel this and have it as what? as a sine of x cos of x over what? Over x. So this is what you're going to have. Applying the limits as x approaches to 0, the sine of 0 gives us a 0. So definitely you're going to have 0. And the denominator x is also a 0. So that's we're going to also have to differentiate again to obtain our limit. We are supposed to differentiate as we apply it here. And that's a product that you are dealing with. So you have to consider the product. That's the product y is equal to u times v. Then the derivative is going to be u, the first derivative, plus v u prime. So this is what you're going to have. So if we're to consider this, applying the product rule, our u in this case is what? The sine of x, all right, times the first derivative of k, which is our v prime. V is cos. So its derivative, remember, that's a negative sine of x, which you can use the formula sheet. All right, so that's plus our v, which is the cos of x, times the derivative of u. U is what? The sine of x. Its derivative is what? Is cos of x, a positive, over what? The derivative of what? The denominator, just like what we had before. So the derivative of x is going to give us a 1. So thus we can have this simplification, and I have our limits at the end as x approaches to 0. Sine times sine, that's going to be sine squared with a negative, plus cos times cos, that's a cos squared x. So take note, this is over 1, so it's not going to affect. So as x is approaching to 0, you're going to substitute a 0 and a 0 here. So this negative sine of what? It's going to be sine of 0 squared. Was going to give us a 0. And the cos 0 squared is going to give us what? A 1. So meaning to say, in this case, we're going to obtain 0 plus 1, which is what? Which is 1. So this is our limit from what we are given. This is the limit from what? The log of y in base of 3. So you can even write in that manner to say, therefore, the logarithm of y in base of 3 is equal to what? Is equal to 1 from what we are given as our limit. Okay, then from what we just obtained, it is a continuation. Find the value of y on 1.1.2. So the value of y, you can simply take it from the log that we are having. So that's from our logarithms. Remember, you can convert this to exponential form, where the log of a inverse of b is equal to c. It follows that a is equal to b to the exponent of c. So that's y in this case is equal to the base 3 to the exponent of what? To the exponent of 1. So y is simply equal to 3. So that is what we're given, simply playing around this information. So y is going to give us a 3. Okay, then on 1.2, a condition for which f of x is what? Continuous. Okay, so they are just trying to play around with us here. We do understand when it is what? Discontinuous. When we are having a discontinuous, we take the denominator and equate it to what? And equate to 0. So what if it is what? It is now continuous. It simply means our denominator cannot be equal to what? Cannot be equal to 0. So that is the condition that you're simply going to use. So for x, all right, 3 to the other side is going to be a negative 3. So x cannot be equal to negative 3. Though x there, we are referring to all the real numbers. So that is what you simply have as we are to consider our revision. All right, question number 2, which was on our derivatives. 2.1, given this f of x, determine the derivative of what? F of x. We are supposed to use this from first principles, all right? So that is 5 marks for that. So if we are to consider our first principles, the first derivative is going to be limit as h approaches to 0 of f of x plus h minus f of x everything over h. So in this case, our f of x is already given. So what we need is f of x plus h, which is substituting x plus h where we have got what? Where we've got x. So it was going to be 1 minus x plus h like this, which is 1 minus x minus what? Minus h if we distribute by that negative that we are given. All right. Then the denominator, x plus h plus what? Plus a 2. So this is what you're simply going to have as f of x plus h. So into the formula, we are going to need the difference of these two. So we can simply even evaluate the difference of these two, f of x plus h minus what? F of x. So this is going to give us our f of x plus h is this one, 1 minus x minus h over what? X plus h plus 2. Then we're going to subtract our f of x, which is this one that we are given here. So we're going to subtract that as it is, which is 1 minus x over what? Over x plus 2. Remember, when subtracting, what we simply need is to have the same denominator. We can find the LCD of the denominators, or you can simply interchange. We take the x plus h plus 2 to the other side, then we take the x plus 2 to the other side. So that's, we can simply add in that manner. All right, so this is what I'm trying to say. We can simply take the x plus 2 this side. So it's going to be x plus 2 over x plus 2. This side, you take this one to the other side. So it's going to be x plus h plus 2 over x plus h plus what? Plus 2. We know that if the denominators are the same, as we can see here, these denominators will be the same. You simply combine by what? Adding or subtracting the numerators. Just combine the numerators together, since the denominators will be the what? Will be the same. X plus h plus 2 into what? Into x plus h. All right. Sorry, that's x plus 2, not x plus h. So we just take the denominators as it is. So this, I mean, the numerators here as they are. So that's 1 minus x minus h into what? Into x plus 2. Okay, minus, there is a negative. Then we're going to take the numerators as they are. So that is simply 1 minus x into what? Into x plus h plus 2, like this. So that is what you're going to simply have from the simplification. So guys, I want you to expand the brackets. You know how to expand here. You're going to simply take x plus 2. It multiplies everything in that bracket. So it's x plus 2 into 1 minus x minus h. You multiply by x, you multiply by 2, then simplify. So if you're to do that expansion on the first one, we're going to have something like x minus x squared minus xh plus 2 minus 2x minus 2h. This is what you must obtain. You do the same thing on this part minus, you expand these two brackets, all right, ignoring the negative. You're going to obtain something like x plus h plus 2 minus x squared minus xh minus 2x. So guys, know your expansion of what? Of brackets, everything over the denominator. So that is what you're simply going to obtain. So as we can see, we simply need to expand here x minus x. That was going to what? Cancel. Okay. Minus x squared minus x squared was going to cancel as long they are the same, because there's a negative here. Minus xh minus that was going to cancel with what? Xh. Minus 2x and what? Minus 2x was going to cancel. Also, there's what? 2 and 2. Positive 2, positive 2. This was going to cancel. All right. So you'll be left with minus 2h minus what? Minus h. So minus 2h minus h is going to give us minus 3h. So that's minus 3h over what? X plus h plus 2, all right, into x plus 2. So that is simply what you're going to have as per our subtraction from these two. If we are to combine, then you apply your subtraction properly. This is what you're going to have. So with this, you're simply going to substitute back into the what? The formula from our first principles formula. We simplify the whole of this part. So it was going to be the limit as h approaches to 0. You take that answer that you obtained, which was minus 3h over x plus h plus 2 into x plus 2. So you're going to take that answer here that we obtained when simplifying. So this is it. Everything is over what? Everything here is over h. So that's over h, like this. So remember, guys, I told you from the simplification of these basics that when we have a fraction like what we have, and there is a term in the denominator, we can cancel it to the numerator. So the h and the h can cancel. A over b over a, like this. This can cancel and you have 1 over b. So that is the case that you can simply use. So meaning to say we're going to have the limit as h approaches to 0 of what? You're going to remain with minus 3 over x plus h plus 2 into what? Into x plus 2. So for this, our limits can be what? Can be applied. We no longer have the h in the denominator. So we can simply consider that limit. So this is going to give us what? As h approaches to 0, put a 0 here. So that was going to give us negative 3 over x plus 2 into what? Into x plus 2. So our h is a 0, remember? So that's simply negative 3 over x plus 2 into x plus 2 simply means what? X plus 2 squared. That's you are considering here 2 brackets. So that's our first derivative with respect to x. That is what you're simply going to have at the end if you were to simplify this properly. So you see, guys, it's just easy like that, just simplification. Go through each and every type according to your syllabus from the first principles. Which ones are you expected to revise according to your syllabus and working with the new textbooks for the new syllabus that you are working with, and also joining the membership so that you don't miss any other revisions that we have from MedZone African Motives. So question number 2.2, it was to determine dy dx in each of the following cases. Simplification is not required. It's not necessary. So the first part, it was y is equal to x squared plus 5 to the exponent of negative 3 over 2. Then we've got sec 5x squared. All right, we've got sec 5x squared like this. So there are actually two terms, like we've got expressions in what? In x. So we're going to consider as two terms, a product. This is u, this is v. So remember, our product rule, the derivative of y with respect to x is going to be taken from u, v prime plus v u prime, like that, where we're going to need to find their derivatives. So in this case, you're going to take your u as it is, which is this part, that's our u, x squared plus 5 to the exponent of minus 3 over 2 times what? The derivative of v. So we have our v here, and we need what? Its derivative. So there is a sec of 5x squared. So when you are given this, we've got a trigonometric function that we are given, and an inner expression. So you're just going to consider the function and its inner expression. So the function is the sec. This is our function. And the inner expression is this one. This is our inner expression. This is our function. So the derivative of a function, a sec, remember a sec changes to sec tan from our derivatives here. All right, our derivatives, a sec is going to change into a what? A sec is going to change into sec x tan x. So that is sec tan, sec tan. So for a function, it was going to be sec of what? 5x squared times tan of 5x squared. All right. That's our function times the inner expression. So the inner expression, that's our 5x squared. Its derivative, drop the power. So that was going to be 2 times 5, which is 10x. All right. So that is what you're going to have. So this is the derivative. So you can simply leave it like this or just write it as 10x sec 5x squared tan 5x squared. So we have differentiated what? V. This is the derivative of V. Then we move on plus what? Plus V. Our V is this part as it is. So that's our V. Just take it as it is. The sec of what? 5x squared times the derivative of what? Of V of U. I mean, U is this one. So we need its derivative. There we've got a power. So we must consider a power 3 or minus 3 over 2. So that's power and function. We don't have a function. This is just an algebraic. So just consider power and what? The inner expression, the power and what is inside. So that's power and inner expression. So power, you drop the power, minus 3 over 2, x squared plus 5 like this, you subtract 1. Remember the derivative, drop the power, subtract 1. So it was going to be minus 5 over 2 times the derivative of the inner expression. So here 2x plus what? Plus a 0. The derivative of 5, that's a 0. So that's simply 2x. So that's the derivative of what? Of u, this one. It's going to be this. So this is the one that we need here. Minus 3. All right, we can just even have it like this. Minus 3 over 2 into x squared plus what? Into x squared plus 5 to the exponent of minus 5 over 2 times what? Times 2x like this. So we can actually leave our answer like this without simplification, as we are told that simplification is not required. Simplification is not required. So you can leave your answer like this. So guys, just go through and verify whatever you do not understand. Let's communicate, but that's simplification is not required. So you can just leave your answer like this. Okay, let's consider another part and see how we're supposed to attempt these typical questions. All right, let us consider this part. All right, simplification again is not required, and that's we are given here. Wherever we see a theta, that's a constant. So theta is just a constant. So the derivative of y with respect to x, since it is a fraction, it was gonna be the quotient rule of v, derivative of what? Of u minus u, the derivative of v over v squared. So we're gonna take our v, which is what? The denominator as it is. So that's theta cubed x cubed minus cot of what? The cot of theta. This is our v times the derivative of what? Of u. So we must differentiate u, this one, the numerator, which is 1 minus sec theta squared x. So guys, we are told that theta is a constant. It is just like a number 2 squared, which is 4. If let's say there was a number there, which is 4, how are you going to differentiate a sec of what? Ax. The derivative of sec ax, if you are to differentiate this, is going to give us a sec of what? Ax, tan of what? Tan of ax. That is the condition that you're going to have. So theta squared, guys, is a constant. So just like a, so it's going to be what? Theta squared, theta squared, theta squared. It's a constant. So that is the derivative of u was going to be simply 1, the derivative of 1, that's a 0, minus whatever that you're going to have there, which is this one, theta squared, sec what? Sec theta squared x, and this is going to be what? Tan theta squared what? Theta squared x, as theta squared. As theta is a constant, so also theta squared is what? Is a constant. So 0 minus this, that's simply a negative. Negative theta squared, sec squared, sec theta squared, sec theta squared x, all right, tan theta squared x. So this is what you're going to have. Or if you want, you can just put the brackets, then you have this one like this, or you can simply have it as it is. So that is the derivative of what you're given. So we have got u, and v and the derivative of what? Of u, minus u, our u is the numerator as it is. So we're going to take the numerator as it is, 1 minus what? So that is going to be 1 minus the sec theta squared x as it is. That is our u, times the derivative now of what? Of v. So this is where our v is. Remember, theta, guys, is a constant. Theta is a constant, just like a number, just like 1. So the derivative, if you're given a constant here, you focus on what? You focus on x. So it was going to be 3x squared times what? The constant theta cubed. So that's 3 theta cubed x squared. All right. So you differentiate x, drop the power, subtract 1. The constant, leave as it is. So cot theta, remember theta is a constant. It's just like cot of 50 or cot of a certain value. It is going to give us what? A numerical value. We are going to obtain a numerical value. And we know that the derivative of a numerical value is just a 2, a 3, a 4 gives us what? A 0. So if you are to differentiate cot theta, because theta is a constant, you are going to obtain a 0, not x. This is not cot x. So if you check the memo, they made a mistake because they took it as cot x. It's cot theta. So that is going to give us what? A 0. So that's here is simply going to be the first derivative of what? Of v, which is 3 theta cubed x squared, like that. So that is what you're simply going to have. So that's the first derivative of what? Of v. Everything that we are having here is over v squared. Our v, as it is, theta cubed x cubed minus cot of theta, but being what? Being squared, v squared. So that is where simplification is not required. We can simply leave our answer like this. All right. So that was it for 4 marks. You can see that was fair enough. So it is just a matter of revision, doing as much questions as you can. Let us consider another one, 2.3. With the aid of what? The logarithmic differentiation, where you introduce the log, ln, differentiate this. So you're going to introduce if y is equal to. So you're going to introduce a ln and a ln. So it was going to be ln y is equal to the ln of what you are given already. The ln of x squared plus 7 to the exponent of what? To the exponent of arc cos x, like this, all right? So we have introduced a ln, but remember, when we have a log of a certain number, let's say the ln of a to the exponent of n, you drop the exponent, so that's n ln of a. So meaning to say the ln of y is equal to, there is our exponent, which is what? Arc cos of x. So you have to drop that exponent and you're going to remain with the ln of what? Ln of a. So a in this case is this part here that we are having here, this one. So it was going to be like this. You drop that exponent. So that's arc cos of x times what? The ln of a. This is our a, guys. The whole part here. Yeah, this one represents our a. Like from this consideration, this whole part here is our a, the ln of a to the exponent of n. So it's n ln of a. So n ln of our a. So it's going to affect that ln as it is, back as it is. So that's the ln of what? X squared plus 7 as it is. All right. But only that we no longer have the exponent. So this is where we are, and we can see that our derivatives can be applied as we are to differentiate with respect to y. So differentiating a ln was going to give us 1 over y. With respect to x, that's we must multiply to dy dx since we do not have x here. Okay, so this is equal to, on the right-hand side, the derivative here is going to be of two terms. The first term being the arc cos of x here. This is a term on its own. And the second being the ln of this whole part that we are given here, which is going to make it to be a product of two terms. So you have to consider the product rule. So this is our u and this is our v. So guys, remember our product rule. All right, so our u is going to be arc cos of what? Arc cos of x times the derivative of what? V. So v is this part. We are to differentiate a ln. And we know that when differentiating a ln, it's going to be, if it is ln f of x, you're going to need the derivative to differentiate that. You're going to need f prime x over what? Over f of x. So in this case, our f of x is this part here, because we're talking about the outer term, the ln, which is on the outer. So you're going to consider the outer, then to the inner one. So the outer is going to be f prime, which is our f of x is what? Is the ln, the one that is inner here. This is our f of x, is the ln of x squared plus 7. So you want to differentiate it. So you see, all right, its derivative is what? What is the derivative? I'm working with a ln again. So to differentiate a ln, what do I need? I need this f of x. So it's going to be our f of x this time for this one. So let's consider it maybe as another function. So this will be your f of x where you need its derivative, 2x over what? That f of x, x squared plus 7 of this function, guys. Take note. But on this one, this f of x is this one as it is. So meaning to say, therefore, the derivative here was going to be 2x over what? X squared plus 7. This is our f prime, the first prime, over what? Over our f of x, which is the ln of x squared plus what? Over the ln of x squared plus 7. So this is what you're going to have. So since we have a fraction and another one here, so simply multiply the denominators together of from this numerator. It is the same as 2x over what? X squared plus 7 times the ln of what? The ln of x squared plus 7. The denominators multiply each other. The numerators, the numerator on its own. So that was the final derivative that you're going to have from what? From v. All right? Plus, remember we are dealing with a product here. So v, we take our v as it is. This is the whole v. This one. The ln of what? Of the ln of x squared plus 7. This is the whole part representing v times the derivative of what? Of u. The derivative of u. U is what? An inverse. We are talking about what? The inverse trig which I said for an inverse trig, do not even worry because you have this one in your formula sheet. You just take from the formula sheet as it is. The inverse trig of a cos is given from here. These are the derivatives, and this is the inverse trig of what? Of a cos. We are dealing with a cos in this question, so we're going to simply take that inverse trig of what? Of a cos, which we are given here as negative. That's -1 over the square root of this. So this is what you're simply going to substitute into the inverse of what? Of a cos as the derivative. So that's -1 over the square root of what? 1 minus x squared, like this. So this is it. Where simplification is to be required, this one, we must consider simplification because it's not part of what we had before. This is a logarithmic, so let us try to just simplify a little bit. As we are simplifying, let's also take y to the other. Remember, we need dy dx. So we're going to multiply by y here, then this side we multiply by what? By y again, so this can cancel. So that's dy dx is going to be equal to y into what? This is same as over 1, so you can just multiply the numerators together. So that's 2x times what? Arc cos of x over the denominator as it is. All right, so that's ln of x squared plus 7 here. All right, here it is okay. Even if we can just, okay, we can just say this is same as over 1. So you multiply the numerators and the denominators. So it was going to be positive to a negative. That's a negative. The ln of ln x squared plus 7, like this. All right. Everything over 1 times the square root of that. That's the square root of what? 1 minus x squared. Okay, so we can actually have it in this manner. We can have it in this manner, then substitute that part representing y in terms of x. Remember, y is equal to what? Y is equal to this part that we are given here as it is originally given. That was our y there. So you substitute that in place of what? In place of y. So therefore, the derivative of y with respect to x, taking y into consideration, which was the ln of x squared plus 7, all right, to the exponent of what? Arc cos x as it was. Then we take this remaining part here in terms of x as it is. So that's into what? 2x times arc cos of x over what? X squared plus 7 into the ln of x squared plus 7, okay, minus the ln of a ln. So that was basically what you're going to have, of which was just a lot of things to consider, but at the end, this is what you're going to have. All right, something like this. So this is what you are going to have as the derivative of y with respect to x from that logarithmic. All right, so you will see, guys, it is a matter of revision. It is a matter of what? Revision, taking into consideration all the basics that you have done. All right, then 2.4, the implicit function that we are given, differentiate, all right, to determine dy dx. So we need dy dx from this implicit. So what you can simply do here, all right, we have to determine dy dx. So for a cos, that's we've got a function. If we are to consider a function and the inner expression, so the function, the derivative of a function cos changes to a negative. So it was going to be negative sine of what? X squared y cubed. That's our function times the inner expression. Our inner expression is what? X squared y cubed. That's a product. So in differentiating the inner expression, we are dealing with what? We are dealing with a product there. So remember your product rule. So you're going to apply the product rule. U is what? X squared. So that's x squared times the derivative of v, which is what? 3y squared. You drop the power, subtract 1. But remember, with respect to x, you must multiply this one with what? Dy dx, since it is of y, but we need what? Dy dx, okay? That's plus our v. Our v is what? Y cubed times the derivative of v of u, which is x. So it's going to be what? X squared is going to give us 2x. So that's times 2x here. There is no need of multiplying to dy dx because it is of what? It is of x, this one. We already have x on that. So that was it on this part. V times the derivative of what? Of u. Plus, we move on. We are differentiating, guys. Remember, with respect to x. So here, 3x is going to give us what? A 3. So that's plus 3, separate as it is. Then y cot 2x. On the other hand, we can see that's a product, just like this one. We have to consider a product. So that's we've got u and v. So from our product rule, u is going to be what? Y there. So that's y times the derivative of what? Of v, which is cot. Remember, cot, when you differentiate, is going to be negative 2 cosec squared. So that's negative 2 cosec squared of what? Of 2x. Okay? Plus v cot 2x as it is. So we're going to take the cot 2x as it is times the derivative of v of u, y there. So y is going to give us 1, its derivative. With respect to x, you multiply by what? Dy dx. So that was times 1 dy dx. So this is what you're going to have. And what we need is to find dy dx from this. And we can see that we have that dy dx from both sides of the given equation. Here, there is a dy dx. Here we also have it. So simply expand brackets and simplify. All right, so let us expand. If we are to multiply here, it's going to be, the first part is going to multiply like the whole of this part here. So that's negative times 3, which is negative 3 x squared y squared. You take the sign as it is, sine x squared y cubed with what? With dy dx. Okay, so that's the first term. Then you multiply to the second term, which is this one. So that's a negative times this is going to be negative 2x y cubed. Then you take the sign as it is, the sign of what? X squared y cubed as it is, plus a 3. All right, so that's equal to, on the other hand, simplify again. So here, if we're going to multiply this, that was going to be negative times y, which is negative 2y cosec squared 2x. Okay, then cot 2x times dy dx. So that's plus cot of 2x dy dx, like this. So this is what you're simply going to have. So from here, we can see that what we can simply do is to collect the like terms. So you're going to consider collecting of the like terms, where we consider the terms with what? Dy dx on one side of the equation. There is a dy dx here. There is also a dy dx. So I was going to simply take this one to the other side of the equation. So I was going to remain with minus 3x squared y squared, the sine of x squared y cubed dy dx. Then taking this to the other side was going to be a negative. So that's negative cot 2x dy dx, okay, equals to what? So we're going to take these other terms to the other side of the equation. So considering this negative to the other side, it was going to be a positive. So we're going to take this whole term to the other side. That's a positive 2xy cubed sine of what? X squared y cubed. All right. Then you take the 3 to the other side. It was going to be a negative. All right. But let's start with this one. Then we're going to write the 3 after. So this is minus 2y cosec squared 2x. Then the 3 is going to be there as a what? As a negative. So if we take the 3, it's going to be a negative 3. So that's the basic idea of what it was going to look like. All right. Where dy dx is what is common, you can factor it out and consider the division. So if you're going to factor out that dy dx and divide, definitely you are going to remain with what? Let's say you factor out this dy dx here, this dy dx. You're going to remain with this part here, this one and this one. Those are the ones that you're simply going to divide on the other side of the equation. So you simply divide there. So that's 2xy cubed sine of what? X squared y cubed minus 2y cosec squared 2x minus 3. Simply divide by what? What was remaining? This part that is remaining minus 3x squared y squared. The sine of what? X squared y cubed. What is remaining here is what? Minus cot of what? Of 2x. So that's basically what you are going to have at the end when simplified. This is what we're going to simply have. So it's a matter of revision. It's a matter of revision, guys. Let's just work out as many questions as we can. All right. So on this part, it was just like this. All right. So that was our derivatives, all right, for this one, question number 2, working with our derivatives. Then the applications of our derivatives on question number 3, we are given this. That was, in this case, f of x, determine the coordinates of what? The turning point. So for the turning points, we simply do understand that the first derivative must be equal to what? To 0. So that's it, guys, to have what? The turning points. So first derivative is equal to 0. So differentiate what you're given here, drop the power, that's going to be 3x squared. Here it's going to give us 2x minus what? Minus 1. And this is a 0. So that is supposed to be what? Equal to 0, this one. So you solve according to any understanding that you have. A factorization, if possible, use that from quadratic formula. X is equal to minus b plus or minus what? Square root of b squared minus 4ac over 2a. Remember your quadratic formula. You're simply going to obtain that minus 2 plus or minus the square root of b squared, that's 2 squared minus 4. Our a is 3, our c is what? Negative 1. Everything over 2 times what? Our a, which is 3. So you're going to solve this equation, guys, using your calculator. X was going to give us 1 over 3, or x is equal to a negative 1. Thus, for these values of x, substitute them into the original function that you are given to have what? To have the turning points for the values of x that you are given. So for that, you're going to have the turning point. The first turning point, when x is 1 over 3, substitute 1 over 3 in place of what? In place of x. Y was going to give us minus 140 over what? 27, something like minus 5,185, something like that. And the other one, the second turning point, when x is what? Minus 1, substitute properly, minus 1 in place of x. Y was going to give us a negative 4, something like that. So that was it. For this one, we have our turning points. And another one, it was to draw up the table right, of x and f of x, where x is ranging from -2 to 2. So that's our 3.12 is simply going to need from x to what? From -2 up to 2, where we're going to obtain the integers -2, -1, 0, 1, up to 2. Substitute the values of x that you're given into our f of x. When x is -2, you put back -2 properly. That was going to give us -7, -4, -1, -4, and 5. If you substitute properly, guys, using our calculator. So after that, you simply draw a neat graph showing the turning point between these values, all right? So we have a turning point, and if we check properly, that's -1, -4. We also have that -1, -4 on our points here. That's a turning point. So this one, it is what? It is a turning point. Remember, that's part of our turning points. So looking into the graph that you're going to have, we can see that from here, the coefficient of what? Of x cubed is a positive. A is greater than 0. That's a positive. So meaning to say we're going to have a shape like this, where these are turning points, right, from our cubic function. So if you're going to consider that, it was going to be something like this, all right? It was going to be something like this. Take note, we have got -1, -2, 1, and 2. So we have got -2 and -7 somewhere below. Then -1 and -4, which is what? Which is a turning point. Then there's definitely going to be 0, -5 below -4, all right? And in between here, a turning point at a third. A third is in between 0 and 1. There's a point where x is what? A third, which is part of our turning point. So this one is a turning point that we have here, all right? Then 1 versus -4, which is somewhere here. 2 versus 5 is going to be up there. So definitely the shape from what we have, something like this, to the turning point, it was going to be to the turning point, to the y-intercept, to the turning point, it goes back like that, something like this. So where this is our turning point, where x is what? A third, a positive, and y is -140 over what? 27. This is the y-intercept, -5 when x is what? 0. This is the first turning point on the left side of our graph, which is where x is what? -1, y is -4. It is also a what? It is a turning point. So these are the points that you're going to mark, and your f of x is drawn. All right, just draw a proper graph from what you're given. All right, so basically you're going to end up with something like that. And 3.14, given that an estimate of the root of this equation, so this is our f of x, exactly what we had before, is what? Close to x, which is what? 1.5. So our x naught is 1.5. So use the Taylor's or the Newton's method twice, all right, 2 times. Determine the better approximation of this root. Provide the correct root in 3 decimal figures, all right? So our f of x is what? X cubed plus x squared minus x minus 5. And its derivative, that was 3x squared plus what? 2x minus 1, remember? So our Newton's or the Taylor's method states that xn plus 1 is equal to xn minus f of xn, remember, over what? The first derivative of xn. So meaning to say from our x naught, the first solution x1 is taken from x naught minus f of x naught over f prime x naught, where our x naught, the first, is what? 1,5. When our x naught is 1,5, substitute into f of x 1,5. In place of x, yes, substitute what? 1,5. All right? that was going to give us negative 0,875. Then on the derivative, you do the same thing of that x naught 1,5. You substitute 1,5 in the second derivative. In place of x, put what? 1,5 in that derivative like that. Substitute properly on your calculator. That was going to give us 8,75. So we have the first derivative from the value that we are given as x. Then we're going to substitute. So x1 is going to be our x naught, which is what? 1,5 minus our fx from that one is what? Negative 0,875. All right. Over what? This is over 8,75. Negative simply is going to be a positive. So simplify, x1 was going to be something like 1,6 was going to be exactly 1,6 from your calculator. So that's, you have to continue. Remember, they said you must apply this one twice. So from our x1, we have to find what? X2. So that's going to be our x2 using the x1 that we obtained. So definitely it's going to be x1 minus what? F of what? F of x1 over the first derivative from that x1. So from our f of x, guys, that as we had here, our f of x before. But this time we need what? F of 1,6. So in place of x, put 1,6 in place of what? In place of x. It was going to give us 0,056 to 3 decimal places. The same thing on the derivative. You put that 1,6, the value of x that you now have in the what? First derivative. Here you put 1,6. You're going to get 9,88. So this is what you're going to need this time for the second what? Beta approximate, where our x1 is 1,6 minus f of that, that's 0,056 over what? The f prime of that 9,88. So that was going to give us the value of x2 to 3 decimal places, 1,594, something like that. All right, so we can see that is just a beta approximate that you're simply working with. Just go through the introduction of each part, understand all the basics as per your syllabus. That is what you simply needed on this part. Okay, let's consider another part. Just gonna quickly have this, guys. We have this as our revision. In 3.2, we have a box of a square base, all right, and no top. Meaning to say it is what? It is open on top. It is to hold this volume. So there's a volume of 100 cubic centimeters. Find the dimensions of the box that will require the least material. So for the least material, that's from the least area, from the minimum what? From the minimum area for the 5 sides. So this one, guys, advantage is that already they gave us a hint on the volume and also on the surface area. So there was no need for you to crack your head to say, okay, it's open on the top. So if it is open, I'm going to subtract that L squared of a square, which I have. No. Guys, already they gave us that from that box, which is open, its volume is now given as L squared times H. And its area is given by this. So what is going to be the least area? Our area is given, guys. Our area, for us to have the least area, we need the what? The first derivative with respect to area must be a 0. But that must be in terms of one variable. Our area is given in terms of L and H. We have L and H. So you're supposed to get rid of one letter here and have it in terms of one variable. So it is either we have our area in terms of the length, or we have our area in terms of what? The height, so that we can have the derivative. So which one is easier here to get rid of? It is H from the volume. We can make H the subject. So write A in terms of what? In terms of L. So to have area in terms of L, we have to make H the subject from the volume. Since volume is equal to L squared H, H is equal to volume over L squared, where our volume is what? 100 over L squared. So this is our H. Wherever we see H, we can use 100 over what? L squared. This is it. So writing our area in terms of L, it means it was going to be given as 4L times H, 100 over L squared plus what? L squared. So this is it. So that is going to be, this is ms over 1. This can cancel L and going to be L. So 4 times 100, that's 400 over L plus what? L squared. So we've got our area in terms of what? In terms of the length. So in order for us to have the minimum value, that area must be what? I mean, its derivative with respect to the what? To the length must be equal to 0. So we're simply going to need what? To differentiate what we are given. So the derivative of the area, 400 over L is same as 400 L to the exponent of what? -1. So to differentiate, drop the power, minus 400 L to the power of what? -2. We subtract 1, remember? So that's minus 400 over L squared. We take it down. It's going to be over L squared. So that's minus 400 over L squared, the derivative of the first part. The second part, drop the power, subtract 1, so that's 2L. So this is it. This is our first derivative, which must be equal to what? Which must be equal to 0, as we stated above. So you're going to simply solve for L in this case, all right, when minus 400 over L squared plus 2L is equal to 0 for us to have the minimum or the least area. So that's it. Let us solve. We can even just take this one to the other side. It becomes a positive. So 2L is equal to 400 over L squared over 1. You can cross multiply this and that. 2L times L squared, 2L cubed is equal to 400. So to find L, simply divide by 2 by 2. So L cubed is equal to what? 200. And to find L, that's the cube root of what? The cube root of 200 that we need, which was going to give us to 3 decimal places 5,848 in centimeters. Remember, that was given these dimensions in centimeters because of what? The volume in cubic centimeters. So it means this length is what? Is in centimeters. So remember, it's a square box. So the box that we have, which is a square, on the base, it's length times length. So we already have the length, I mean the dimensions of everything on the base, because we're told that it has a square base. So the other dimension is going to be for the height to the other box, to the other part section, the height in between. So that height is taken from where? From here. We already have that height as the subject of formula here, height in terms of L. So to find the height from the length that we just calculated, let us find our height. So our height, therefore, was going to be what? Was going to be 100 over L squared. This is our L, 5,848 squared. So that was going to give us the given height at 2,924 in centimeters as well, just like the height that, just like the length that we had. So that was it, just basic. Basically, we just needed this information, 5 marks. All right, then 3.3, suppose that the area, the radius of a sphere, all right, is changing at an instantaneous value, all right? So that is what we have from our related rates of change. So here, the radius is the one that is changing. So that's the change in radius of 0,1 centimeters per second. At what rate is the area of the sphere growing? The area, the rate of change affecting the area when the radius is 10 centimeters. So guys, we are already given area in terms of the radius. So we can formulate an equation for the change in area if we have the derivative of area with respect to what is changing. What is changing what is the radius. So we must have the derivative of the area with respect to the radius times what is changing. That is with respect to the radius. What is changing is the radius. So these two are supposed to be exactly the same. So that's it. So what is the derivative here of area with respect to r? You simply have to drop the power. So that's 4 pi times 2r. So 4 pi times 2, that's going to be 8 pi r like that. That's our derivative. Times what? The change or the increase in that radius. This is going to give us the change in what? The change in area. So 8 pi times our radius is what? Is 10 times the change. Our change is what? 0.1 per second. So it's going to give us the change in area per what? Per second. So you multiply all this, that was going to give us the change in area, 8 pi. It was going to give us 8 pi, which is as a decimal, 25,133. That is area, square centimeters per second. That's the change in area, remember. So it's going to be square centimeters per second from what we have. So that's what we have on question number 3. It was just direct like that. All right, then let us move on to question number 4, part of our integration. And question 4.1, we're given determine the integral of y with respect to x in each case. All right, 4.11, that's the integral of what? X over the square root of 1 minus 25 x to the exponent of 4 with respect to x. So this one, if you're going to check properly, it is part of our trigonometric substitution, the part of our trigonometric substitution, trying to have these trigonometric substitutions, as I said before, right? Did I have an introduction about this one? I don't think I had an introduction, but these ones, you know them, guys. And according to the new, this is the formula sheet from this question paper. It seems like they left out some of these ones. All right, this is actually, they left out, I'm gonna need the old formula sheet, because on these ones, on these integrals, these are the ones that we must use. We must apply or work with these integrals. So from what we have here, we do not have the format of exactly what we are given there. They left, I didn't notice that now from the new formula sheet, that other one is not given. It was from the old formula sheet. Let me see if I can have an old one quickly. Okay, so you can see that from the old one, this one, we have that, all right? So this is an old formula sheet that we had. So meaning to say on this one, you had to know this, all right, from your trigonometric substitution. I want something like this, all right, remember? So, or let me just write my question here so that we can simply understand each other. What am I trying to do here? Remember, our question was the integral of, it was given as x over what? The square root of 1 minus 25 x to the power of 4. So this is our integration. So I want us to see that we can have or formulate that part here for 1 over a squared minus x squared. So to have that, here there's still x, so we still have a lot, but let us just rewrite as it is. So it was going to be x over what? The square root of a squared. That's 1 can be written as what? 1 squared. So we have that a squared, 1 squared, minus the x now from here, x squared. It is 25 from that. 25x to the power of 4 is same as 5x squared to the power of 2. The square root of 25x to the power of 4. It is what? 5x squared. You simply have what? The square root of that. So that was what? That was going to be rewritten, or we can have it as what? 5x squared to the exponent of what? Of 2. So this is what we need. But we have x in the what? We have got the x, this one, in the numerator. So we have to get rid of that x. So to get rid of that x, that's where our substitution now is taken from the part of u here. Let me just try. Let me see. This one is a highlighter. This one, the part of what? X squared. The 5x squared that you're given there is the one that you're going to concentrate on. So meaning to say we can let our u using substitution be equal to that 5x squared, so that its derivative with respect to x is going to give us 10x. So we drop that one. So make dx the subject, as we're going to need to replace it here. So that was going to cross multiply, then divide by what? 10x. So that's du over what? Over 10x. Okay? So you're going to substitute that into this integral. So it was going to be the integral of x over what? The square root of 1 squared minus, okay? 5x squared, the whole part of 5x squared is what? Is our u. So that's u squared. We are getting there. We want to get to this state, all right? Times what? Our dx, where our dx is what? Du over what? Over 10x. So definitely the x and the x was going to cancel, the numerator denominator concept, and you take the 1 over 10, because this is going to be 1 over 10. You take it out of the integral. You remain with the integral of 1 over the square root of what? 1 squared minus u squared with respect to u. Are we seeing this is exactly what we have here, where we are given that in order for you to integrate this, the answer is going to be what? Arc sine of that. So our answer was going to be 1 over 10 arc sine of what? What is representing our a? Our a is represented by 1. Our x is represented by what? By u. This is what we see. So it was arc sine of x over a, arc sine of x. Our x is what? Is this one, our u, with respect to u, over our a is what? 1 from a squared. That's a 1. Okay, so that's how you integrate. So it's arc sine here, all right, plus the constant of integration. But remember, we are using something that we introduced as part of our question to answer this u, where our u is what? 5x squared. So we bring that at the end of our calculation, 5x squared plus what? C. So that is how you could have just integrated that one using what? The trigonometric substitution, which I'm going to elaborate into questions, more questions. I'm just going to try to work out more questions so that you can understand. Like I said, let us join the membership so that we don't miss any of the other revisions that we can have. So that was the first part. We are done. All right. The second one, 4.1.2, given this integral, that's 4.1.2, gonna have to integrate the sine cubed of x cos to the exponent of x here. That's all right. We have got an odd power and an even power. It is better for us to expand the one that is what? Odd. So expand what? Expanding odd. In this case, is going to be better. So that's a sine can be written as what? A sine of x times the sine squared of x. We're expanding the odd exponent, all right, times the cos as it is with respect to x. Why expanding the odd is because we need the cos, the cos from a sine squared of x, where we do understand that the sine squared of x equals to what? 1 minus cos squared x from our trigonometry. We do understand that, all right, from our trigonometry here, can make it the subject of the formula from here. So that is what you simply play around with from what you're given. All right. So that is what we need to substitute here. So it's going to be sine of x. The sine squared is represented with what? 1 minus cos squared of x. All right, times the cos to the exponent of 4x with respect to x. So to integrate, here we can just expand, all right, or we can just, it is up to us what exactly we're going to need. We can use by inspection method, or we can just expand. Since we are to expand, we can just expand the cos and leave the sign outside. It is up to you. Or you can expand with the both. It is up to you. So yeah, let me just choose to expand with only one here. But we can just use both of them with the sign of x. So expanding with cos to the exponent of 4 times 1, that's cos to the exponent of 4x minus cos and cos, you add the exponents 2 plus 4, that's what? A 6. So this is what you're going to have. Using the substitution, we're going to let u to be equal to the cos, the one that is raised to an exponent, and its derivative with respect to x is going to be negative sine x, and that's our dx is going to be negative du, that du over negative sine x, actually, that's du over negative sine x. So substituting that here, it was definitely going to cancel the negative sine x, and this was going to what? Was going to cancel with this one, and the negative, you take it out of the what? Out of the integral. So you are left with this one. That's u. Remember, cos is what? It's u. So that's u to the exponent of 4 minus u to the exponent of 6 with respect to u as we are substituting. So it's going to be with respect to u. Then we can integrate this negative here, u to the exponent of what? Integrating, you're adding, remember, so that's 5 over a 5 minus, you add here 7 over a 7 plus the constant of integration. So that's minus, our u is what? Cos. So minus times here is going to be cos to the exponent of 5x over 5 minus times minus. That's a positive of cos to the exponent of 7 over 7, substituting the cos of x. So basically, that is what you're going to have. Okay. This is revision, guys. I don't know if I'm rushing. If I'm rushing, guys, you just update me and say, no, that was a rush. But I just think from what we have covered, we are able to understand from our revision purpose. All right. So let us move on 4.1.3, which is part of our fractions, and from that, long division was to be used, as we can see that the denominator here has got a lesser degree compared to the what? To the numerator. So you can simply apply the long division in this case. So that's 4.1.3, that's the integral of 2x cubed plus x squared minus 4x plus 1 over what? X minus 2 with respect to x. Using the long division, I'm gonna consider that. All right, the other one that I just did, this one, you could have applied that inspection method. So you can apply the inspection and see if you are on the same page from our understanding. All right, let's consider long division, guys. This is lesser degree. So we're just gonna take that x minus 2, our divisor, into the what? Into our dividend, which is 2x cubed plus x squared minus 4x plus what? Plus 1. Divide to obtain what? To obtain the quotient here. So that's it. Remember the division concept, always first term to the what? First term. Divide 2x cubed, divide by x. That's 2x squared. Then you multiply every term that you are given there, every term. So 2x squared times x, 2x cubed times 2 times minus 2, that's minus 4x squared. Then we do subtract, remember? So after that, we subtract. So divide, multiply, subtract, and repeat like that. So subtracting, that's a 0 here. X squared minus 4x squared. Minus minus, I mean x squared minus minus 4x squared. It was going to be a positive. So that's 5x squared. All right. Then you drop the exponents after that. You drop whatever that you have, and you repeat. So drop what is remaining. Minus 4x plus 1. Divide again. First term to the what? First term minus it was going to be positive. So this is 5x squared. So 5x squared divided by what? Divided by x is going to give us 5x. So that's a positive 5x here. Multiply to every term. 5x times x, 5x squared. 5x times minus 2 minus 10x. Subtract. So this one is 0. Minus 4 minus minus 10. Minus 4 minus minus 10. That's a positive. So that's going to be 6x. Then you drop what is remaining, which is what? Which is plus 1. Divide first term versus first term. 6x divided by x, that's a positive 6. Multiply everything. 6 times x, that's our 6x times negative 2, negative 12. Subtract to obtain what? The remainder. In this case, we're going to have the remainder. This cancels. So 1 minus minus 12, that's a 13. So we've got a remainder of what? Or a remainder of 13 from what we have. So meaning to say, we can rewrite whatever integral that we're given here in terms of our quotient plus the remainder over the divisor. So our quotient is what we have here. So that is our quotient. We take it as it is 2x squared. 2x squared plus 5x plus 6 as it was, plus what? The remainder, our remainder is what? A positive. So just going to take as it is plus 13 over our divisor in this case, which is what? X minus 2 over x minus 2, our divisor here. So that's it. We have applied our long division. This is where we are. So we can simply integrate this with respect to what? With respect to x. So integrating this, that was gonna simply add our power. So that's 3, 2x cubed over 3 plus, this is 1 already. So if we add a 1, that's gonna be 5x squared. 5x squared over 2 plus 6 is gonna give us, with respect to x, 6x, then 13 over this. Remember, it's going to be ln of this. So that's plus 13, the ln of what? X minus 2 plus the constant of your integration. You are done when it is like this. So guys, basically, that is what you're going to have from this one, 4.1.3. Okay. Then let's see another part, which is 4.1.4, a product. And that product, you can use what? By parts. Under integration, when you've got a product like this, that's simply what? By parts. So 4.1.4, we understand that it's going to be the integral of what? The integral of x e to the exponent of what? 4x with respect to x. So that's our f of x from I let, which helps us to pick our f of x in this order, where we have got an algebraic and what? Exponential. The algebraic starts. So it is better for us to have our f of x as what? The algebraic, choosing f of x. So our f of x is going to be x, where we find its derivative, that's 1. And from what is remaining, that's our g prime, that's going to be our g prime x. All right, which is e to the exponent of 4x with respect to x. If we integrate this, you obtain gx. Remember, that's an exponent, so you divide by the first derivative, which is what? 4. So that's it, guys. Applying our by parts formula, f of x, that integral of f of x g prime x. Where was it actually taken? From f of x by what? Gx minus the integral of f prime x gx dx. So that's it. Substituting into this formula, we can see that the integral of what we are finding here was going to be simply given as what? F of x, which is x times our gx, which is this one, e to the exponent of 4x over 4 minus what? So that's minus the integral of f prime. Our f prime x is 1 times gx, which is what? E to the exponent of this, like that. You integrate. That's it. So you're going to simply have to integrate, simplify, and what? Simplify and integrate. That's the case. So simplify, this is same as over 1. Simply multiply the numerators x, e to the exponent of 4x over 4 minus what? So integrating, going to take 1 over 4 out of the what? Out of the integral sign. That was 1 over 4. Then we integrate e to the exponent of what? 4x, which we integrated before here and obtained this. So it was simply going to remain like that, as e to the exponent of 4x over 4 plus the constant of integration. So simplify. As we are done, we can factor out what is common here. It is fine. We can just leave it like that. That's e to the exponent of 4x over 4 times 4, which is 16 plus c, like that. You can even just ignore the simplification. Leave it like that. So that was the integral by parts. So that is it. So many ways of working your by parts. I introduced so many ways, guys, from the list. So just choose which one that you understand of the methods. All right. That is what we have. All right. 4 marks. 4.2 from this, you need what? Partial fractions. So definitely using our partial fractions where there is a repeated linear factor raised to the exponent of what? Of 3. That's a repeated linear that we have in the denominator. So that's to integrate this, 2x squared minus 10 over x minus 4 cubed. You are going to need to resolve this into partial fractions, which we can use our repeated linear from our formula sheet. Our repeated linear, let's hope they did not remove this one because they are removing and adding and so on. So this is it. A repeated linear is here. F of x over x plus a to the exponent of n. You're going to have a over that, b over that. So the exponents are increasing 1, 2, 3, 4, up to the last one. So that is how you simply expand a repeated linear. So that's here. 2x squared minus 10 over what? X minus 4 cubed is equal to a over, you take the x minus 4 to the power of 1 plus b, you take that x minus 4. We are increasing up to 3. We are increasing what? The exponent. So that's squared plus c over what? X minus 4 cubed up to the exponent of 3. So that's it. That's what you have here. So what you can simply do is to find the values of A, B, and C. If you were going to treat that addition simplification, you're going to simply equate the numerators. 2x squared minus 10 is equal to A, this one into this, x minus 4 cubed over x minus 4. You're going to remain with the 2 of them. So that's x minus 4 squared. All right, x minus 4 squared plus b, this one into this, you're going to remain with what? Only 1 of the x minus 4 plus c, this one into this, they cancel. So that was going to be a 1. So it's simply a c. So this is it. To find these constants a, b, and c, let's consider the bracket that there is x minus 4, x minus 4, which is what? A linear. So we can let that bracket of x minus 4 be equal to 0. So x must be what? X must be 4 to obtain a 0 here and a 0 here. So substituting 4, that was going to give us 0, 0, 0, 0 throughout. And C is going to be calculated from that. So that's 16, 32, 32 minus 10, which is what? Something like 22. So that's 22 equal to C. So we are done. We cannot equate any bracket. It's only one bracket that is the same. So what you can do is now expand these, all right? So expanding the left-hand side is going to be 2x squared minus 10. Expand here, x minus 4 squared, guys. Please expand it properly. You are going to obtain something like this with a 16 here. Then you multiply by what? By a, because there is a outside. So a times x squared, that's ax squared. All right. A times negative 8x, that's negative 8ax. A times 16, that's positive 16a. All right, so we have done multiplying by a. Then after that, we move on to what? To b. Multiply by b here. That's expanding. It's going to be bx. B times negative 4, that's negative 4b plus what? Plus c. Okay, so after expanding, what you can do is to equate the coefficients of corresponding. So you can even consider the coefficient of x squared. On the left-hand side, there is a 2 on x squared. On the right-hand side, there is x squared here. The coefficient is what? Is a. So meaning to say 2 is equal to a. All right, just like that. Then let's consider another one, the coefficient of what? Of x. On the left-hand side, we do not have x, so that's a 0. But on the right-hand side, we've got x here, so its coefficient is what? Negative 8a. There is also x here, its coefficient is what? Positive b. Where we have the value of a, remember, a is what? 2. So you're simply going to put that 2 here, that's negative 16. So 16 is equal to b. If you solve properly for b, that's it. We have expanded. So let us put back whatever that we have here. After that expansion, since we have the value of a, b, and what? And c. So it was going to be simply our a, which is what? 2. So that's 2 over what? X minus 4. Our b, that is what? 16. So that's plus 16 over what? X minus 4 squared. And our c is what? 22 over what? X minus 4 cubed. X minus 4 cubed. So with this, we can integrate. We have substituted our a or b and c. So that means that expression was going to be rewritten in this manner from what we were given here from this integral that we had. So we're simply going to integrate that, all right? So that is what it simply means, guys. So it simply means here, we are simply going to integrate this with respect to what? With respect to x. This is what we have. So that means integrate this whole part with what? With the respect to x. So integrating here, that's going to be a ln here too. Ln of what? X minus 4. Okay. And the next one, we can use the substitution. All right, very sorry for that. We can just use the substitution or just inspecting. Just okay. Can just inspect or just substitute where I can treat u as x minus 4. So du dx is 1. So that's du is equal to dx. But it's going to be the integral of what? 16 over u. This whole part is what? U. So that's u squared with respect to u, since dx and u are the same. 16u squared is same as 16u to the exponent of minus 2. So we can integrate this by what? Adding 1 here. So it was going to be 16u to the power of minus 1, which is simply over the new exponent minus 1. You add 1, you divide by the new exponent. So that's minus 16 over what? Over u. All right, so this is what we're going to have. So it's minus 16 over what? Over u. Minus 16 over u. What is u? X minus 4. Just like that. So you do the same thing on the other one, just like that. Here, it's going to be 22, the integral of 22 over. This is u. So that's u to the exponent of 3 du. Remember, du and dx are the same. So that's 22 u to the exponent of minus 3 du. Integrating, you add 1. So that's 22 u to the exponent of minus 2 over minus 2, which is negative what? 11 u to the exponent of minus 2. That's negative 11 over u squared. So that's negative 11 over u squared. Our u is what? X minus 4. So that's x minus 4 squared, just like that. So this is what you're going to have from what we are given, and we add the constant of integration. This is revision. This is revision, guys. I just hope we are together here. So that was basically that's what you're gonna have. So it's a matter of playing around with the given information, just try performance, also revise, go through the basics that can actually help membership and so on. So let's consider our question number 5. So 5.1, you are given determine this, all right, where we have got our limits from 0 to infinity. All right, so there was just a little mistake on the limit there. It was supposed to be negative infinity, but anyways, according to the positive infinity, let's see how it was going to look like if we are to consider the positive infinity as we are given. We just need to integrate this. All right, so that's the integral of, all right, 1 over this. This is same as 3 minus x to the exponent of a half. So 1 over that is going to give us a negative exponent. This is going to taken up, and we bring the negative to that. So that's with respect to x. So we can simply integrate this by inspection or substitution, all right? Inspection, that is from our formula sheet. Remember, guys, I told you about these inspections as part of our derivatives. If we are given something of this nature as our answer from this, all right? So this is what we simply need from what we are given. So as we have got 3 minus x to the exponent of minus half. That is our f of x, this one, raised to the exponent of n times. We do not have this part, the derivative is actually a 1. The number that is there representing our f prime x is what? Is a 1. So if we are to consider according to our f of x here, its derivative is not a 1. According to our f of x, which is 3 minus x, its derivative is what? Negative x. So on here, we have got a positive 1. All right. Sorry, not negative x, but negative 1 here. So 0 minus 1. Here we have a positive 1. So meaning to say on our answer, which is this one that we must have here, just put a negative. Since the first derivative is a negative, but you do not have that negative, so simply put a negative on your answer. So to differentiate this whole part that we are given, we're simply going to take our f of x as it is 3 minus x to the exponent of n plus 1. So we add 1 on our exponent. That was going to give us a negative what? A positive half over what? N plus 1, the new exponent over a half. So this is what you're going to simply obtain from integrating that one by simply applying your inspection. But like I said, since our derivative here is supposed to be what? A negative, and we have a positive, we're going to put a negative on our answer, all right? So that is what you're going to have. And if you simplify this, minus 1 over a half, that's minus 2. And this is going to be the square root of this to the exponent of half is the square root of what? 3 minus x. So this is what you're going to have after what? Integrating that. So guys, I just took that one into consideration. After integrating, we saw that we're going to remain with minus 2, the square root of what? 3 minus x. That is after what? Integrating. Then we apply our limits. So I want you to see now with this infinite that you're given, guys, you're going to substitute here in place of x. It was going to be minus 2, the square root of 3 minus infinity. Where 3 minus infinity is what? It's minus infinity. So it's going to be minus 2, the square root of minus what? Minus infinity. Okay? Minus, we subtract when x is what? When x is a 0 there. So it was going to be minus what? Minus 2 square root of 3 minus 0. So 3 minus 0, that's what? That's a 3. So this is what you're going to have. So if we were to consider these guys, we can see that we cannot simplify this. We cannot simplify the square root of minus infinity. No, this one cannot be simplified. That one cannot be simplified. Negative, negative, here it's going to be positive 2 square root of 3. So that's why I'm saying the error, when it is like this, you leave your answer like this, all right? But it was just a mistype. It was supposed to be negative infinity. When it is a negative infinity, it was going to make sense because you're going to substitute a negative infinity here, negative, negative infinity, which is what? Positive infinity. So it is going to be minus 2 square root of positive infinity, all right, plus 2 square root of 3, which is an infinity. The square root of an infinity value is going to be infinity, guys, plus 2 square root of 3. And infinity plus 2 square root of 3 is going to be infinity. It's not going to end. So if the limit was a minus infinity, this was going to be our answer. But for a positive infinity that we're given, you're just going to leave your answer like this. It cannot be simplified further. You cannot obtain the square root of minus infinity. It cannot be a way that we take out the negative out, then we say it's a positive. No, it cannot be like that. It cannot be simplified. We cannot simplify square root of minus values. So whether it is a minus infinity, it's a negative value, that's not exact. It cannot be what? Evaluated. All right, so that was it. So here, for exam, for what we're given, we're just going to leave our answer like this. But for the exact value that was supposed to be given, it was minus infinity, and your answer was going to be infinity like this. All right. So that was the case of this question from 5.2. We are given this, and from these two equations, 5.21, calculate the coordinates of what? Points of intersection when the two graphs are equal. Simply equate them. So 10 minus x and this one, equate them together. So that's 10 minus x is equal to minus x squared plus 10x minus 8. So let's solve for x. We can simply take these terms to the other side of the equation. So it was going to be positive x squared. 10x to the other side was going to be negative 10x. It's negative x, negative 10x, which is negative what? 11x. Then 8 to the other side was going to be a positive. So 10 plus 8 is what? Is 18. So solve this equation, which you can solve by quadratic formula or by factorization. As we can see, the coefficient of x squared is 1. So we're just going to have 2 brackets x and x. Then you concentrate on the what? Factors of the constant 18, which adds up to negative what? 11. Factors of positive 18, which adds up to negative 11. That's negative 9 and negative 2. So these are the factors, negative 9, negative 2. Equate to 0. So x is going to be positive 9, or x is going to be a positive what? A positive 2. So remember, these are points of intersection, a point x versus y. So to find the y value, you can substitute in any one of these equations. So I'm just going to use what? 10 minus x. Since y is equal to 10 minus x, when x is 9, all right, when x is what? 9, substitute 9 here. So that's 9 versus what? 10 minus 9, that's 1. And another point of intersection, when x is 2, substitute 2 here. 10 minus 2, that's what? That's 8. So these are the points of intersection that you're gonna consider for the graph that we are having there. All right, that was the condition. All right, 9 versus 1 and what? 2 versus 8. Then from there, make a neat sketch, show the enclosed area. All right, let's see. All right, if we're going to sketch this one, as of the quadratic, it was going to be difficult for us to just solve using factorization. So you can just have a sketch without considering its solutions, because it is also 2 marks for that. So let's not consider. All right, the quadratic a is less than 0. That's a negative, so it's going to be concave down. So we're going to have our graph being concave down and having the y-intercept at what? At -8. That's a -8 and being concave down. So it was going to be something like this, concave down, all right, with y-intercept at what? -8, all right, which is for our quadratic function, all right, and the linear function, it was going to be with a negative gradient, so we need a line like this, but remember these two, they're going to intersect, the two graphs will intersect, so let's say our graph is like this, right, but they must intersect. All right, they must intersect, so it's going to be something like this. All right, all right, so you can just have here something like that, so that they can intersect at 2 points. The first point of intersection, that's 2, 8, 2 versus 8, so it simply means here x is 2, since the point is what? 2, 8, and this is 9 versus 1, so the x value is 9. So this is it. That is what you're going to have. So that's the graph of y here, the quadratic, minus x squared plus 10x, all right, plus 10x minus 8. And the linear is y is equal to what? 10 minus x, all right. From our N4, guys, we can simply sketch this. So the area, because we need to represent where the area is to be calculated, all right, representing the strip, they show the enclosed area. So the area enclosed by the two graphs is this one. This is the enclosed area. And the representative strip, since our limits are for x, we've got the x values, we're going to use the representative strip for what? For x, like this. So our representative strip is for x. So that's the sketch for 2 marks. It was actually fine for you to obtain the 2 marks. All right. So that was it from what we are given. Then 5.2.3, calculate the magnitude of area, 4 marks. So that's 5.2.3. So the magnitude of area with respect to x from the strip that you are given of x, we're going to take the graph that is on top minus the one that is on the bottom, since there are 2 of them. So that's the integral of y1 minus y2, top minus what? Top minus bottom, from A to B. So the top graph is this one, so that's y1. The one below is the linear function, so that's y2. So you're simply going to subtract and integrate that. You are done. So that's it. So our AX was going to be the limits, the strip for X from 2 to what? 2 to 9. All right, then you're going to take y1, which is the one on top, on that curve that is bounded. The one that is on top is what? The quadratic, minus x squared plus 10x minus 8. Then we subtract y2, where y2 is the one below for that graph, which is what? The linear function 10 minus x. So you subtract that 10 minus what? X. All right, that's 10 minus x. So that's it. So this is it here. We're gonna subtract, then apply our integration to find exact values. So that was gonna give us ax 2 to 9, and this is gonna be minus x squared plus 10x minus 8, minus times 10, that's minus 10, minus times minus x, that's a positive x. So simplifying, collecting the like terms, we're gonna obtain the like terms. So that's gonna be minus x squared. We've got the like terms here, 10x and x. This is 10 plus 1, which is 11x. All right. Then there's minus 8 and minus 10. That's minus 18. With respect to x, we're simply going to integrate this and have our limits. So remember, integration, we add 1 on our exponent to the exponent of 3 over 3. This is already 1. So if we add 1, it's going to be 2. So that's 11x squared over what? Over 2. All right, 18, this is minus 18x. So that is what you are simply going to have. And we need to substitute the given what? The given limits from 2 to what? From 2 to 9. So the upper limit, do that, guys. In place of x, you put 9 in place of x minus 9 cubed over 3, 11. 9 squared over 2 minus 18 times 9. This is our upper limit minus the lower limit when x is what? When x is 2. 2 to the exponent of 3 over 3, 11. 2 squared over 2 plus 18 times 2. So you are going to substitute and simplify that. So that was going to give us the area. So simplifying this, the first part was going to give us something like 81 over 2. The second part was going to give us negative 50 over 3. So use your calculator to combine these two. Combine, you are going to have 343 over 6. Negative, negative, that's a positive, all right? So that's simply something like 57,167 square units. You're dealing with what? With the area. Area in what? In square units. So that is how you simply play around this type. All right, so that is what you simply needed from this one, applying our area. So same as the volume, as it is what rotated about the x-axis on 5.24, we can have what? The volume calculated from our integration again. So this is the volume with respect to what? With respect to x. So that's pi. It's going to have the top y1 squared minus y2 squared with respect to x from a to b. So y1 is the one on top, which is that minus x squared, that part that we're given. So you're going to substitute that, then you square it, two brackets that you're going to open and what? And you square. So that one, guys, you're going to do it. You are going to do it. You take this one, minus x squared plus 10x minus 8, you square it, minus y2, that is the one below, 10 minus x. So that's our 10 minus x. We square it again. So you're gonna expand, all right, then integrate with respect to x. So this is it as we do understand our expansion of brackets. Here there are two brackets. Here there are also two brackets. So make sure that you expand properly. This whole part here, if you expand this one, it was gonna give us, guys, x4 minus 20x cubed 116x squared minus 160x plus 64x. So 64, all right? Minus, you expand this one, that is simply gonna give us 100 minus 20x plus what? Plus x squared. So that is from your expansion of what? Of brackets. That is what you're gonna simply obtain. And from here, we can expand the brackets of the second bracket here with a negative, then collect the like terms, all right? So you're gonna expand by that negative here. So negative times 100 minus 100 times 20, negative 20, that's positive 20x, negative times x squared minus x squared. So simply, this is what you're going to consider collecting your like terms. It was going to be x to the exponent of 4, all right, minus 20x cubed. There is x squared here, sorry, here. So it's going to be 116x squared minus x squared. So 116 minus 1, that's positive 115x squared minus 116 plus 20, considering the like terms, that's minus 140. X, all right, so it's going to be minus 140 x, all right. Then 64 minus 100 is minus 36. So this is collecting your like terms, then integrate from this, then apply your limits just like what we had before. You're going to have your volume with respect to x. All right, so add exponent, that's plus 1 is going to be 5 over 5. All right, here if we add 1, it was going to be minus 20x to the power of 4 over 4. So this is minus 5. All right, minus 5x to the power of 4. All right, we do the same thing. We add 1, so that's a 3. 115x to the exponent of 3 over what? Over 3. Minus 140 plus 1 is going to be x squared over 2, so that's minus 70. So that's minus 70x squared. All right, minus 36, you're going to put x, so that's minus 36x there from 2 to 9. Substituting, guys, your upper limit, just like before, you put the upper limit in place of x. All right, so in place of x, you put 9. You were going to obtain something like 4779 over 5. Okay, minus the lower limit when you put a 2. If you put a 2 in place of x, you're going to obtain negative 1784 over what? Over 15. That is what you're going to have. So you can simplify by combining both. All right, negative and negative that you have here is going to give us a positive. So you add those two. That was going to give us our volume of pi times 16121 over 15. All right, which is the same as 3,376,374. This is volume in what? Cubic units. So it's going to be in cubic units like that. We've got the volume there. So simple like that. That is how we can play around with these typical questions. So you need just to work out as many questions as you can. It's all about the issue of what? The issue of revision. It's a matter of revision from what you can see. So that's our Vx here. All right, we have got the volume. Let's consider another one, 5.3, which is part of our second moment of area. All right, we've got a circular lamina. So that's a sketch. We're going to have a circular lamina with a ring, which is a disc, which we're going to take the distance here, the perpendicular distance to be x. All right, so that's for a radius of a circle, or for a radius of a circle r. Then the strip is going to be delta x. That's from that strip that you're given. So the perpendicular from to the plane is our x. So the small letter r is representing x, which is the perpendicular, which is the distance of what? The perpendicular distance. So remember that if you're dealing with the second moment of area, it is supposed to be taken from the integral of r squared dA, which is the distance being squared. And here we are talking about the area of what? Of the strip. So the distance squared, r squared, in our case, r is what? Is x. So you're going to consider that one as what? As x squared. So that is our distance. So what we need is the area of the strip, the dA. So it follows that the area of the strip, if we're going to take this strip here, is going to be a rectangular from that circle with 2 pi x. All right, remember our radius is x, so it was supposed to be 2 pi r, the circumference. So it's 2 pi x times delta x, which is what? The strip that is the thickness that you have of that. So length times width to have the area. So that was going to be 2 pi x times what? The thickness of that, which is what you have. So this is what you're going to have here. If we are to integrate, it means our integral was going to be r squared, where our r is what is x. So that's x squared times our dA. So this is it. So it's going to be 2 pi x times what? Delta x. So this is just like delta x for the strip of x. It simply means what? Dx, meaning to say you're gonna integrate here with respect to x. What about the limits? The limits are of the radius of the circle r from r, for that r from 0 to the radius of the circle, where our diameter is what? Is 14. It means our radius diameter over 2, 14 over what? 14 over 2, which is 7 centimeters. So the limits will be from 0 to 7, which is from 0 to r. Our r is what? Our radius, 7 centimeters. So that's 0 to 7. So that's simply like that. You can integrate, you have your final answers. Take the 2 pi out. So that's 2 pi. Considering the like terms, you've got x squared times x. So that's x cubed. So that was going to be x cubed. Simply integrate that one, then substitute your limits, you are done. So that's our second moment of area. So add 1, so that's x4 over 4 from 0 to 7. So that was going to be 2 pi times upper limit is 7 to the exponent of what? Of 4 over 4 minus the lower limit when x is what? When x is a 0. So that is what you're going to simply have. If we are to simplify this, we have got the second moment of area from there. So this was going to give us 2,401 over 2 times this pi, which is as a decimal, 3,771,482. Remember, second moment of area in what? Units to the power of 4, to the exponent of 4. So that's our units are centimeters here. Remember, this is in centimeters. So that's centimeters to the exponent of what? To the exponent of 4, like that. So that is your second moment of area from our understanding, as we are dealing with what? With a circular lamina. So just also consider other videos on membership, which explains much as introductions so that you can understand more about what we are dealing with. All right, number 6, we are given determine the particular solution of this. All right, so this is from the first order. From our first order, what we need is to separate here by what? By separation. So that's e to the exponent, oh, that's x squared, sorry. E to the exponent of y dy dx is equal to 1. Okay, let's take the dx this side. So just multiply by what? By dx by dx. This is going to cancel. So x squared e to the exponent of y dy is equal to dx. We are separating, remember? So dx, here there is x, it must be with dx. So how can we have that? Simply divide by what? By x squared, so that this can what? This can cancel. So we're going to have dx over this, which is the same as x to the exponent of minus 2. If we take it up, it's x to the exponent of minus 2 with respect to x. Why rewriting in this manner? So that you can be able to integrate properly. All right, integrating this, e remains as it is. All right, then x squared, you're going to add 1. So it was going to be x to the power of minus 1 over minus 1. So that's minus 1 over x. All right, so this is negative 1 over x plus what? The constant of integration. But remember, they actually specify that we need a particular solution. This here is representing what? Our general solution with a constant. So to find the particular solution, you have to use the limits. I mean the values of x that and y that you're given. X is 1, y is what? Y is a 0. So that's a 0, x is 1. E to the exponent of 0, that's 1. Minus 1 over 1, that's minus 1 plus c. So you can find the value of c. That's going to be 1 plus 1, which is 2. So that's our c. Okay, so we can rewrite now our particular solution as what? E to the, from here, from our general solution, e to the exponent of y is equal to minus 1 over x plus c, where our c is what? Where our c is a 2, like that. So that is what we had, just a matter of working out more questions. It's just about revision, guys. All about revision. All right, we can see that it was just easy like that. Then 6.2, the general solution. The second order, we need to integrate until we have the value of y. So here they need the general solution. We're going to write our answer in terms of what? In terms of the constants. All right. So that's it. But we can see that here, before we do our integrals, there is an e to the exponent of minus x, which is disturbing. So we have to divide by this one throughout. Divide by e to the exponent of minus x, divided by e to the exponent of minus x. So that was gonna give us what? All right, we are dividing here, same basis, we subtract the exponents, minus, so that's a plus. So that's 4 plus x, 4x plus x, which is what? 5x, e to the exponent of 5x. Here, these two, we're simply gonna cancel e to the exponent of minus x and what? E to the exponent of minus x. You remain with the sign of 3x, which we can now integrate, as we have got this separately until we have y is equal to something. So we integrate with respect to x, also integrate this with respect to x. So that was going to give us dy dx. From the left-hand side, we're going to have what? Dy dx. If we divide by the derivative, so it's e to the exponent of 5x over 5, the derivative. Then sine is going to give us a negative cos 3x over what? The coefficient of x, which is 3. So that's plus the constant. We can start with a. Then we do integrate again. Remember, we need y there. So we have to integrate this with respect to what? With respect to x, so that we can have y. In our case, y is equal to, okay, this is going to be, there's 1 over 5 here, so it's going to be 1 over 5 times, remember, e gives us e to the exponent of 5x over 5, okay, minus, a cos changes to a sine, so that's the sine of 3x over what? Over 3, but already there's this 3 that we are given, all right? Then a with respect to x, if we integrate, is going to give us what? Ax plus what? The constant of integration, another constant, we can even use b. So that is what you're going to have at the end. So therefore, y is equal to, you multiply this, e to the exponent of 5x over 5 times 5, that is 25, minus the sine of 3x over 3 times 3, that's a 9, plus ax plus what? Plus b, like that. So that is basically what you're going to have from the given information. From this information that we had, it was simply a matter of playing around with these questions, just trying to understand, guys. Let us do all these revisions in what? In light, as we are preparing ourselves for the exams ahead of time. But for now, that is it. Till we meet again.